our fifth unit. So once again I want to just recap that fifth unit now. I'm using earphone. I don't know why you are unable to hear unable to hear me. So now I want to start now. So in the previous class we have started fifth unit, that is Laplace transforms. So now here you can see the definition once again. So that is nothing but, once again I want to read that definition now. That is, let f of t be given function for t greater than 0, then Laplace transform of f of t is denoted by Laplace of f of t, that is L of f of t, or f bar s, and it is defined as L of f of t is equal to f bar s is equal to integral 0 to infinity e power minus st f of t dt. Okay, so then we have started, and we have then I have written linearity property of Laplace transform. Okay, that is nothing but it is given if L of f of t is equal to f bar s and L of g of t is equal to g bar s, then L of c1 f of t plus c2 g of t is equal to c1 L of f of t plus c2 L of g of t. Okay, now I have done the proof also. So it was in the previous class. Then afterwards we have started, I have given you that Laplace transform of some elementary function. So what are the elementary functions? I have given nearly 8 elementary functions I have given you. So in that you can see first one is L of f of t. Unit, that is Laplace transforms. So now here you can see the definition. Most of you don't have link also. Once again I want to send you link. Can anyone from civil, can you once send the link in the group? Now you can see here Laplace of 1, as I have told you, that is nothing but 1 by s, that is nothing but of s greater than 0. Here by taking the definition of Laplace transform I have shown you how to derive or how to solve that, and we got L of 1 is equal to 1 by s. Okay, so after that I have shown you these are nothing but Laplace transform of L of e power at, L of e power minus at. Okay, I don't want to see the comments right now, because if I see the comment I can't start right now. So most of you have joined right now. Here only 39 students have joined right now. So here these are the Laplace transform of some elementary functions. We have 8 elementary functions here, and then based on this we have done some problems. So what are the problems here? First problem was find L of sine t plus 2 sine of 3t. That I have shown you. If a problem is given in this way, then how we have to solve that. So as I have told you, this is nothing but L of C1 f of t plus C2 g of t is equal to C1 L of f of t plus C2 L of g of t. So this is equal to, here as I have told you, from linearity property we can separate the constants here. So here 5 L of sine t plus 2 L of sine 3d. If it is given in this way, so we can write by linearity property constants outside, and then 5 L of sine t plus 2 L of sine 3t. Okay, now as I have told you, here 5 into L of sine t. So as we have a formula here, sine at, L of sine at is equal to a by s square plus a square. Here in this problem we have sine t, so we don't have a is nothing but we have to consider as 1, so this becomes sine 1t. So in the place of a we have to put what? 1. So 1 by s square plus 1 square we got, plus 2 into 3 by s square plus 9 we got. So as you know, here I have written the formula, you can see. So yesterday, I mean on the other day, we have done two problems. Okay, so one is this and second one is this one, L of 1 plus 2 root t plus 3 by root t. So let us start third problem based on these formulas. These are the formulas we have of Laplace transform. Now let us start third problem. Third problem is let us write third problem now. Find L of t square plus 1 whole square. This is the problem given. If a problem is given in this way, then we have to expand this. If you write the solution now you can see, we can first we write f of t. What is f of t here? F of t is equal to t square plus 1 whole square. Now we can expand this. This is equal to a plus b whole square. So t square whole square plus 1 square plus 2 into t square into 1. I have expanded this one in terms of a plus b whole square. So now this is equal to, now this becomes what? T power 4 plus 1 plus 2t square. Now this is nothing but what? F of t. Okay, now we have to find what? Laplace of f of t. So Laplace of f of t is equal to L of, I have to write the whole term inside, that is L of t power 4 plus 1 plus 2t square. So after writing this is equal to, now you just write separately, you write L of, for each term, L of t power 4 plus L of 1 plus 2 into L of t square. Now this is equal to, now we have a formula. The formula is here, on the other day I have given you the formula, that's nothing but L of t power n. Here I can write, since L of t power n is equal to n factorial upon s power n plus 1. So now by using this formula we can apply here now. Now here you can see this is nothing but L of t power n. This is L of 1. This is 2 into L of t power n. Now if you apply this formula for this one, now we can write this is equal to, now here n is nothing but 4. So I can write 4 factorial upon s power 4 plus 1 plus L of 1. On the other day I have shown you the formula. L of 1 is nothing but L of 1 is nothing but 1 by s. So I can apply it directly in the place of L of 1 as 1 upon s. After that, plus, now I write 2 as it is, then L of t power n. L of t power n is nothing but, here you can see n is nothing but 2 here. So if you apply this formula here, then this becomes into 2 factorial upon s power 2 plus 1, that is s power n plus 1 is nothing but s power 2 plus 1. So this is equal to 4 factorial. If you write 4 factorial, if you expand 4 factorial, as you know how to write that 4 factorial. 4 factorial is equal to 4 into 3 into 2 into 1. So that is equal to 4 3 is 12, 12 2 is 24, 24 into 1 is 24. So 4 factorial is nothing but how much? 24. So 4 in the place of 4 factorial, I can write that as 24 upon s power 5 plus 1 by s plus 2 into, again here 2 factorial is equal to 2 into 1. So that is equal to how much? 2. That is 2 factorial. So I can write here in the place of 2 factorial as 2 upon s square plus 1. Sorry, s cube we have to write. S power 2 plus 1, that is s cube. S power 4 plus 1 is s power 5. Now in the last step you can write this is equal to 24 upon s power 5 plus 1 by s plus 4 by s cube. So this is the answer. This is the answer of L of t square plus 1 whole square. So you can write at last, therefore L of t square plus 1 whole square is equal to 24 by s power 5 plus 1 by s plus 4 by s cube. So this is the solution here. Now I want those who have joined right now, just they are giving the attendance and just leaving from here. So I want to tell you once again that you have to give the attendance when I ask you to give the attendance in the comment box. Right now I am not accepting anyone's roll numbers here. When I ask, you have to start giving. So most of you are just giving the attendance and leaving here from here. So you give, I will ask you to give your attendance at last, not right now. So this is the problem now. The third problem what I have given just now is That is nothing but, you can see most of you, I hope you have understood this. So this is nothing but L of t square plus 1 whole square is nothing but if L of f of t, you can see it clearly. Okay, so if you want to write in your classwork, you can also write that most of you are saying that just turn the camera and so on. You can adjust in your phone also. Now this is the third problem we have completed right now. Don't be hurry. I'll take your attendance at last. Don't post your roll number as well as your branch right now. When I tell you to post, you then only you post in the comment box. Right now, please listen what I am teaching here. So this is now the problem of how to find L of t square plus 1 whole square. I hope you have understood this third problem. Now I'm just taking out this third problem now. I'll do fourth problem right now. Now let us have a fourth problem now. Fourth problem I'll write on the paper right now. Just you go through this one and don't be hurry. We'll get attendance at last. I hope you are all following me and you are able to hear me also. So now the fourth problem is Laplace of cos cube 2t. Okay, so this is the problem now. Now we have to do this problem by using Laplace transform. Here the question will be asked in the question paper like, find the Laplace transform of cos cube 2t, or find L of cos cube 2t. It will be asked in this way. If it is given this way, now we don't have any formula like L of cos cube 2t. Okay, so we have only formulas like L of, I'll show you the formulas here. Here we have a formula like L of sin 80, L of cos 80, L of sin h80, L of cos h80. But we don't have a formula L of cos cube 80 and so on. So for that sake, what you have to do is, you have to write the formula. You have to remember the formula of, we know that we have a formula. Which formula you have? Cos 3 theta. We have a formula of cos 3 theta. L of cos 3 theta is nothing but 4 cos cube theta minus 3 cos theta. Okay, so this is the formula we have. So if you have, by this formula we can do this problem. We have to rearrange the given problem. So here we have, in the place of theta we have 2t, so I can write here cos cube theta. So here you have a cos cube theta. So that cos cube theta, for how we can write this now, I write like 4 cos cube theta is equal to, now I take this minus 3 cos theta to cos 3 theta, that becomes cos 3 theta plus 3 cos theta. Now I write this as cos cube theta is equal to 1 upon 4, and in bracket you can write cos 3 theta plus 3 cos theta. Now here, as I have told you, 2t is nothing but theta. Now I can write, in the place of theta you can write 2t, so I write L of cos cube 2t is equal to 1 upon 4, and in bracket you can write, in the place of here we can write 1 by 4 L of 1 by 4 L of, you can write this whole term, that is cos 3 into, in the place of theta you have to write 2t plus 3 into cos, in the place of theta you have to write 2t. So you can write flower bracket or you can write box. Then afterwards this is equal to, now I can write 1 by 4 outside, so just put the box here and write L of cos, now here 3 into 2t, that is nothing but how much, L of cos 60, just close the bracket, and then plus you write here 3 is constant now, so 3 you write outside, then you write on L of cos 2t, just close the bracket now. So after closing the bracket, now since L of cos 80 is equal to, cos of 80 is nothing but what, s upon s square plus a square. We know L of cos 80 is equal to s upon s square plus a square. Now I apply here, because we have cos 60 cos 2t, so we have to consider a as 6 here and a as 2 here. Now if you substitute in the formula, this is equal to 1 upon 4 in bracket, in the place of s you have to write s only upon, no, s square plus a is nothing but 6, as I have told you, so here this becomes 6 square, that is 36, then plus 3 into, again here cos 2t, again cos 80 we have, so I can write s upon s square plus a is 2 here, 2 square becomes 4, okay, so now just close the bracket. Now this is nothing but L of cos cube 2t is equal to 1 upon 4 in bracket s upon s square plus 36 plus 3 into s, 3s upon s square plus 4. So this is the answer for this question. Hope you have understood. So this is the formula for as L of cos 80, and by this we solve this problem. So this is the problem. Hope you have taken in classwork also. Only 42 students have joined right now. I don't know why most of you are not joining the class. So please concentrate right now. If you have any doubt, you can inquire me after the class on WhatsApp also. So this is the question for 5 marks you will get, not for 2 marks. Okay. So this is the fourth problem we have done. Now this is these are very important problems. If you don't concentrate, then it will be a problem for you, as I have told you. And now I will I'll do the problem based on sine cube 2t now. So that will be helpful for you, because these are the formulas. Those who are going to take this, you can take in your classwork. Otherwise, let us I'll give you the notes. If you are concentrating, or if you are taking that in your notes, this will be helpful for you. Otherwise, if you don't understand, then I am helpless. I don't know whether I will get the time after the holidays or not. So it's my duty to explain you, and I have to complete the unit now. So now let us do which problem now? Fifth problem. So now fifth problem is L of sine cube 2t. As you know, these are the formulas which you have studied in your intermediate. This is nothing but cos 3 theta sin 3 theta formulas. So previous we have used cos 3 theta formula. Now we use sin 3 theta formula for this problem, because here we have sine cube 2t. Now let us apply the formula. I'll write here. We know that what is the formula you have? Sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So this is the formula. Now here we have sine cube theta. This is nothing but, as I have told you in the previous problem also, 2t is considered as theta. 2t is taken as theta. Now I have to convert this in terms of, because we have here 4 sine cube theta. Now I have to rewrite this formula so that we can apply in the given problem. Now you can see here we have 4 sine cube theta. If you take out this to other side, that becomes 4 sine cube theta is equal to 3 sine theta. Now this sine 3 theta goes to this side. This becomes sine 3 theta. Now this becomes sine cube theta is equal to, I take this 4 to other side, that becomes 1 upon 4. In bracket I write this same 3 sine theta minus sine 3 theta. Now you got sine cube theta. Now you can see in the question it is given, find the Laplace transform of sine cube 2t. Now here in the place of theta we have 2t. Now if you rewrite the given problem, now if you write sine cube 2t is equal to 1 upon 4 in bracket, I can write 3 sine 2t minus sine 3 into 2t. Now you can see here sine cube 2t, in the place of theta we are substituting 2t, that becomes 1 by 4 3 sine 2t minus sine 3 into 2t. Now if you apply Laplace for this one, that becomes L of sine cube 2t is equal to 1 upon 4. Now L of, now you can put the box here, that becomes L of 3 sine, we have 3 here, you write down once, 3 sine 2t minus L of sine 6t. Now close the box. Now here I can write 1 upon 4 1 upon 4 in box we can write 3 L of sine 2t minus L of sine 6t. Now this is equal to 1 upon 4 3 into sine 80. Sine 80 is nothing but a by s square plus a square from this formula. This is the formula we have. L of sine 80 is a by s square plus a square. So if you apply the formula, that becomes a is nothing but 2 here, 2 upon s square plus 4 minus, again here's L of sine 80, that becomes 6 upon s square plus 36. Now close the bracket. This is equal to 1 upon 4, and in bracket you get 6 upon s square plus 4 minus 6 upon s square plus 36. Now you will get this answer. Now this is nothing but L of sine cube 2t. This is the answer for the given question. Hope you have understood. I hope you have understood this problem. Now let us go for next problem. Next problem is, this is the 5th problem. Are you taking in the classwork or shall I continue? I'm continuing now. This is the 5th problem we have completed. Now let us have 6th problem. 6th problem is, okay, so if you are taking screenshots, no problem, then it will be good for you so that we can continue. Now let us have next problem, that is nothing but 6th problem, that is nothing but Laplace, find Laplace of cos square 4t. this is the problem now. This is very important, because you will get one problem from this for 5 marks. So if you concentrate, then it will be helpful for you, otherwise then it will be a problem for you. So now here we have to find Laplace of cos square 4t. Now here we have a formula, we know that we have to write here. So here you have to remember the trigonometric formulas also. So what is the trigonometric formula we have here? Cos square theta is nothing but 1 plus cos 2 theta upon 2. This is the formula for finding the given problem. Now here you can see this is nothing but theta. You have to consider that as theta. Now when you apply in the given problem, here what is f of t given? F of t is nothing but cos square 4t is given. Now when you apply in the given problem, this is equal to 1 plus cos 2 into theta is nothing but 4t, so I write 4t here, okay, then upon 2. So now this is nothing but f of t, okay. So now after when you apply Laplace, then this becomes L of cos square 4t is equal to L of 1 plus cos 8t upon 2. I take common 1 by 2 here. If you take 1 by 2 common, then I can write Laplace of 1 plus cos 8t. Now this is equal to 1 upon 2. Put the box here. Laplace of 1 plus Laplace of cos 8t. Okay. Now this is equal to 1 upon 2 into Laplace of plus Laplace of cos 8t is nothing but s upon s square plus a square. A square is nothing but 8 square. So that is equal to 1 upon 2 in bracket you have to write 1 by s plus s upon s square plus 64. Now you can multiply with this, or else you can put the same, and now this is the answer for that. You just take on this problem, or you can hope you have taken the screenshot. Now let us have 7th problem, where the thing is the problems are looking same, but the formulas we have to use, the formulas of trigonometry should be remembered so that we can do the problems. But the thing is you have to remember Laplace transform of 7 elementary functions. Okay. Now let us have next problem. Next problem is somewhat different. These are all very easy topic, but the thing is if you concentrate, then you can do every problem. Now let us do the next problem, that is nothing but find. Next problem, which I think this is 7th problem. This is 7th problem. Okay, so I will. You want to take the solution? Take this 5th solution. If you want to take the screenshot, you can take 5th screenshot. This is 5th one. Now this is 0. Okay, now this is sixth one. If you want to take the screenshot, you can take, and then afterwards you can copy in your notes also. This is sixth one. Now after this sixth one, now let us do seventh problem. Seventh problem is find Laplace of, the problem will be given like find Laplace of sine 3t sine 2t. The problem will be given in this way. Okay, so this is the problem given. Now for finding this problem, you can see the problem is given in product. If a problem is given in product, then you have to make the problem in terms of addition or subtraction. Then only you can apply Laplace, otherwise you can't. So let us apply now. So we have a formula in your trigonometry. There is nothing but here you can see if you multiply and divide by 2, then this becomes 2 into sine 3t sine 2t. So I apply here 2 sine A cos b. I'm sorry. We have a formula 2 sine A sine b, because we have both sine functions here. 2 sine A sine b is equal to, we have a formula that is nothing but cos of A minus b minus cos of A plus b. So this is the formula given now, because we know this formula. This is the formula we have in intermediate. Now we apply this formula for the given problem. Let us apply this formula for this problem now. Now here this is nothing but A sine A, and this is nothing but sine B. Okay, now when you apply for this problem, this becomes what? 2 sine, let us rewrite the given problem, 2 sine 3t sine 2t is equal to cos A minus B. A is nothing but 3t minus B is nothing but 2t minus cos A plus B, that is 3t plus 2t. Now this becomes cos t. Now minus cos of 3t plus 2t is nothing but cos 5t. Now based on the given formula, we have written the given problem. Now this is nothing but sine 2 sine 3t sine 2t is nothing but cos t minus cos 5t. We have made this problem in terms of addition and subtraction, so that we can apply Laplace transform. Now the given problem is nothing but Laplace of sine 3t sine 2t. So this can be written as, I can write this as Laplace of, I multiply and divide the given function. So I write a Laplace of 1 by 2, and in bracket you can write 2 sine 3t sine 2t. Now close the bracket. Now I can take that 1 by 2 outside. So if you take 1 by 2 outside, this becomes Laplace of 2. Now you can see 2 sine 3t sine 2t. If you want to write floor bracket, you can. Now I have taken this 1 by 2 outside. So 1 by 2 if you take outside, then Laplace of 2 sine 3t sine 2t. So this is equal to, now 1 by 2, now this in this term, in the place of this term I can write this term, because sine 2t minus sine, 2 sine 3t sine 2t, I can write cos t minus cos 5t. So Laplace of, I can write here cos t minus cos 5t. So now separating the whole terms, so this becomes 1 by 2 in bracket Laplace of cos t, close the bracket, minus Laplace of cos 5t. Just put the box. Now you can see this is equal to 1 upon 2 Laplace of cos 80 formula we have to apply here. Laplace of cos 80. Now Laplace of cos 80 formula is s upon s square by a square. So now L of cos 80 is nothing but 1 upon s upon s square plus 1 square. Now put the box here. Then minus Laplace of cos 5t, that is nothing but Laplace of cos 80. So a is 5 here. Now as you know the formula, that is nothing but s by s square plus a square is nothing but 5 square. Okay, so put the box. Now this is equal to 1 upon 2. Then put the box, you get s by s square plus 1 minus s by s square plus 25. Now this is the answer for this given problem. So problem is nothing but, if you want to take the screenshot, you can take. I'm seeing the comments, and most of you are just doing the time pass here. So remember, I'll give you right treatment at right time. Don't worry. If you don't want to, if you are unable to understand, if you are unable to concentrate or you want to listen, please keep quiet. Why you are sending all those comments? I don't understand. So most of you are coming for attendance, it seems. These are because if you don't know the basic things, if you don't know the basic things, if you don't know basic formulas, you won't understand. Or else, if you are not trying to understand the given problem, or else if you concentrate carefully, if you don't understand first problem, then you can understand second problem. Try to concentrate. Or else, if you go through the given problem, if you take the screenshot, or if you take in the classwork, and if you try to understand after the class, or if you do once, or if you do twice in your classwork, then it will be helpful for you. So this is the 7th problem. So I am seeing all your comments, don't worry. Just take those who are serious enough, because we won't continue this again in the classroom. This is damn sure. This is the 5th unit we are going through. Those who have joined, we have completed 7 problems. First we have completed the definition. This is the 5th unit. name is Laplace transform. We have completed the definition, then we have completed the property of Laplace transform, and then we have written Laplace transform of some elementary function, and then based on that elementary functions Laplace transform, we have done some of the problems here. In every problem there will be a formula. Okay, if you know Laplace transform of elementary functions, then only you can apply here, and if you know the trigonometry formulas, then only you can able to do the problems. Otherwise you lose the marks, though it is very easy to do because this will be asked for 5 marks. Here nothing, I mean, this is very easy. If you are finding difficulty, I don't know where you are finding, you just call, reply, or you can call me after the class. If you are unable to understand, I will make you understand. Just go through, you try to understand, you try to go through this, or if you are writing, no problem. If you want to take screenshot and then you want to write in the classwork, you can write classwork afterwards. Okay, thank you. Now, so he is saying that you want I don't know why they are saying that you can turn your phone otherwise. So now, so this is the problem. Now let us have eighth problem now. If you want, I'll send you the PDF. Don't worry. So if you are unable to, unable to take the screenshot also. Now next problem is eighth problem. Eighth problem is find the Laplace transform of f of t is equal to e power t 0, 0 less than or equal to t less than or equal to 1, comma t greater than 1. This is the different problem now. Now you can see this problem is somewhat different now. Now here, before the problem was we have only one function. Here we have twice. This is a periodic function. Now we have to write the formula. Now you know the formula of Laplace transform, that is Laplace of f of t is equal to integral 0 to infinity e power minus st f of t dt. Now I write once again. Here we know that what is the formula we have, L of f of t. We won't use Laplace transform of elementary function here. We use the main definition formula here. L of f of t is equal to integral 0 to infinity e power minus st f of t dt. This is the formula we use here. Now you can see how we apply here. Now here this is the limit of t from varies from 0 to infinity. Now here we have 0 less than or equal to t less than or equal to 1, then t greater than 1. So I can write this in the form of integral 0 to 1 e power minus st into f of t dt plus, then here I write from 1 to infinity e power minus st f of t dt. Now you can apply f of t by seeing the limits here from 0 to 1. Here from 0 to 1 we have f of t as e power t, so we write that is equal to integral 0 to 1 e power minus st is as it is, we write, into, in the place of f of t we write e power t, then dt plus integral again 1 to infinity e power minus st. Here from t greater than 1, t greater than 1 in the sense 1 to infinity, 1 to infinity. What is the f of t there? F of t is nothing but 0. So in the place of f of t we write 0 dt. Why I am writing here from 1 to infinity in the sense t greater than 1, that means from 1 greater than 1 to infinity. So in the place of 1 to infinity f of t will be 0. When 0 to 1, when 0 to 1 we have f of t as e power t. Okay, so now this is equal to, now here 0 to 1 e power minus st e power t dt. So I can write integral 0 to 1, okay, 0 to 1 e power minus, here you can see bases same, power should be added. If your bases are same, power should be added. If you add that, that becomes minus st plus t, and then you can write dt here. So after writing that, plus integral 1 to infinity, 1 to infinity e power minus st into 0 is nothing but what? 0 dt. So you have to leave this function now. If you leave that function, integral 0 to 1 e power, so if you take minus common, that becomes minus of s, okay, minus s minus 1 of t. So you can see minus into s minus s into t minus st, then minus of minus plus, then here we have plus, minus of minus plus 1 into t is t. So I am rewriting this term as this one into dt. Okay, then afterwards, after writing this one, now we have a formula. Since integral of e power ax dx is equal to e power ax by a, we have a formula. So if you have a formula, then you can apply here. You can see a is nothing but here minus of s minus 1. So here you can see x and dx is nothing but x is t here. Now in the place of dx we have dt. So you can write this is equal to e power minus of s minus 1 into t. Now after writing, because this is e power ax, a is nothing but I have told you minus of s minus 1. So minus of s minus 1, in the place of x we write t upon minus of s minus 1. Now we have limits here. What are the limits we have here? 0 to 1. Then this is equal to, now you apply the limits here. So this becomes e power minus of s minus 1 into, in the place of t if you substitute 1, that becomes 1 upon minus of s minus 1. Then upper limit minus lower limit, then minus, in the place of t substitute 0, that becomes e power 0 upon minus of s minus 1. So now this can be written as, this is equal to, I can write that as 1 by s minus 1 is 1 my, you can write this as e power minus of s minus 1 upon minus of s minus 1. Then here minus we have, minus of minus we get plus 1 upon, you can write s minus 1. So this is the answer for the given problem. If you want to take, you can take, otherwise I'll send you the PDF. So this is the given problem here. Okay, now shall we go for next? Have you taken the screenshot now? Now this is the 8th problem we have completed. Now let us go for next problem. That will be the 9th problem now. Ninth problem will be, find Laplace of f of t let us do this last problem and then we will complete. We will stop here today, and tomorrow we will have class at the same time, that is at 3 o'clock. Tomorrow we are going to start a new topic, that is first shifting theorem of Laplace transform. So only 5 minutes, give me 5 minutes so that we can complete our last problem. This is very important, it is asked many times. Find Laplace transform if f of t is equal to sin t 0. So here sin t varies from 0 less than or equal to t less than or equal to pi. Now 0, at 0 f of t t varies from t greater than pi. So this is the problem given. This is very important. This type of problem will come in exam. So here we have another formula. So we know that here first let us write the given problem in Laplace transform formula. That is nothing but we know L of f of t is equal to, what is the formula here, 0 to infinity e power minus st f of t dt. This is from t lies from 0 to infinity, but here we have a division here. Now I can write this as L of f of t is equal to integral 0 to pi into e power minus st f of t dt. Now you can see here from t lies from 0 to pi, so I have written 0 to pi e power minus st f of t dt plus integral now t greater than pi. So I have to take from pi to infinity e power minus st f of t dt. Now after this is L of f of t. Now when you apply f of t, so it becomes integral 0 to infinity 0 to pi e power minus st. In the place of f of t, you have to write sin t because sin t dt, because t lies from 0 to pi. So 0 less than or equal to t less than or equal to t, 0 less than or equal to t less than or equal to pi. So plus integral pi to infinity e power minus st. Now when t greater than pi, so we have to write f of t as 0. So this becomes e power minus st into 0 dt. So this is equal to now integral 0 to pi e power minus st into sin t dt. Now we have a formula. So what is the formula? Since integral of e power ax sin bx dx is equal to e power ax upon a square plus b square in bracket a sin bx minus b cos bx. This is the formula we have. So now this formula we apply here, because here e power ax sin bx, so here instead of x we have t here. Okay, so now when you apply the formula, wait a minute, for 2 minutes we will complete the problem, then you can give the attendance now. So when you apply here, this is in this form. So e power ax sin bx dx. So a is nothing but here minus s, x is nothing but here t. Now sin b is nothing but 1 here, x is nothing but t here, dx is nothing but dt here. Now when you apply this formula for this problem, so this answer will be e power minus st, okay, upon a is nothing but, I have told you, s minus s, so that becomes minus s square plus b is nothing but, I have told you, 1 square, then plus in bracket you can write a sin bx. A is nothing but, I have told you, minus s sin b is nothing but, I have told you, 1, isn't it? 1 into x is nothing but t, so you write down sin 1 into t is sin t, minus here you can see b is nothing but, I have told you, 1, so 1 into cos b is nothing but again x, so b is nothing but again here 1 into x is nothing but t, so you can write t here. So that becomes minus s sin t minus 1 into cos t. So now we have limits here 0 to pi, so we have to apply the limits now here. So if you apply the limits now 0 to pi, so for the whole term you have to apply in the place of t. So now when you substitute in the place of t pi and 0, then this becomes e power minus s pi upon minus s square is nothing but s square plus 1, and then in bracket minus s sin pi minus cos pi. Okay, then this is upper limit I have applied, and then minus lower limit is nothing but 0 we have to apply for this one. That becomes s square plus 1, and in bracket you can write minus s sin 0 minus cos 0. So this is upper limit minus lower limit. Now this is equal to, I can write this as e power minus s pi upon s square plus 1 in bracket minus sin pi is nothing but 0, sin pi is nothing but 0. So first term becomes 0 minus sin pi is 0, so I have written 0. Cos pi is minus 1, so I have to write minus 1 here. So close the bracket for this one. Then minus e power 0 is 1, so I write 1 upon s square plus 1. And then sin 0 is 0, so in bracket write first term is 0, minus cos 0 is 1, so I write 1. So at last this is equal to e power minus s pi upon s square. So this is for whole term, so put the bracket here, so s square plus 1, and here you don't write s square plus 1 because we are taking it starting of that one. For put you write yes, no problem, don't write this one bracket for this. Now e power minus s pi by s square plus 1 into minus of minus is 1, so I write 1 here, and then minus of minus plus 1 upon s square plus 1. So you can write at last, this implies e power minus s pi, e power minus s pi plus 1 upon LCM is same, so s square plus 1. So you can see e power minus s pi into 1 is e power s pi plus 1 by s square plus 1. This is the answer for this, and I hope you have understood. So you can write